Alright guys, today we are finding the greatest common factor of polynomials. This is an intro for our next chapter where we're going to be talking about factoring, which is really just FOILing working backwards. So in a multiplication problem, the numbers multiplied together are called factors. The answer to a multiplication problem is called the product. So in the multiplication problem, 5 times 4 equals 20. 5 and 4 are factors, and 20 is the product. If we reverse the problem, 20 equals 5 times 4, we can say that we have factored 20 into 5 times 4. In this worksheet, we will factor polynomials. So in this multiplication problem, if we are to distribute 2x through, we end up with 2x squared plus 8x. 2x and x plus 4 are the factors, and 2x squared plus 8x is the product. If we reverse this problem and state it the opposite way, we can say that we have factored 2x squared plus 8x into the two factors, 2x and x plus 4. So for these first few problems, we are going to name the factors and the product of each problem. So our factors are our pieces. These are our two pieces, 5 and x minus 7. I'll put it in parentheses since it originally was. And then our product is when they come together, when they have been multiplied. So we have our two factors, 3x as well as x plus 9. And then our product is 3x squared plus 27x. We have our two factors here, negative 10x and x minus 6. Our product is negative 10 x squared plus 60x. And lastly, actually, I'll give you guys a second. Write down your two factors and your product. Our two factors are 4x y squared and 3x plus 8y. Our product is 12xy squared plus 32xy cubed. So the first step in factoring polynomials is to factor out the greatest common factor, GCF. We're going to talk about that a lot. This is the largest integer and the highest degree of each variable that will divide evenly into each term of the polynomial. Factoring is the reverse of multiplying. So this is kind of like dividing. It won't necessarily look like a division problem in a lot of cases, but it can. And I'm going to show that out quite a lot. So in the polynomial, 5x minus 35, 5 is the largest integer that will divide 5x and 35. And we cannot factor out any variable because of the second term, 35. It does not have a variable part. So to factor 5x minus 35, we write it as 5 times x minus 7. So our GCF 5, I can think of dividing each of these terms by 5, which leaves me with x and with negative 7 and the 5 on the outside. This is our factored form. For this specific problem. We can continue that on this next problem. In the polynomial, 3x squared plus 27x, 3 is the largest integer that will divide both 3x squared and 27x. We can also factor out an x because each term has at least one factor of x. So basically, you look for the term with the lowest degree of each variable. So this is our factored form here. How did we get there? Well, we thought about dividing each of these by 3x. So the 3's canceled. One of the x's canceled on top. On this one, both x's canceled, and 27 divided by 3 was 9. So if you notice, after all that canceling, I'm left with x plus 9, and since my GCF was 3x, it's on the outside. We will continue on here. In the polynomial 12x squared y squared plus 32xy cubed, 4 is the largest integer that will divide 12x squared y squared and 32xy cubed. We can factor out an x and a y squared because each term has at least one factor of x and 2 factors of y. So, I'm going to do a little more work here. We've got 12x squared y squared. I'm going to write out all of the factors of 12. 1, 2, 3, 4, 6, and 12. If you didn't know that, I'm going to give you guys a factor chart, and you guys can see these factors here for 12. It should help you out. And then, when it comes to the letters, the variables, I've got x, and y, and y. I'm just trying to make this very visual for you guys. For 32, xy cubed, we write out the factors of 32. That is 1, 2, 4, 8, 16, and 32. We've got 1x and we've got 3 y's. Now, how do we find the GCF? You find the biggest number in both lists. 4 is in both lists. Then you figure out how many letters you can remove. Since this is our smallest amount, that's what limits us. And since this is our smallest amount, that's what limits us. That's why they told us our GCF, our greatest common factor, the biggest thing in both is 4xy squared. That's how we got the GCF. Now, if I rewrite this, I realize I'm doing a lot of extra work because it literally tells me the answer up there. I'm going to think about dividing my terms by this GCF. I know the GCF has to go outside my parentheses. And then once I complete this division, I'll be good to go. So 12 divided by 4 is 3. X squared and x cancel to just a single x, and these y's both cancel out. So I have 3x first. 32 divided by 4 is 8. The x's cancel, and the y's cancel to 1y. Okay, so like I wrote up here, factoring is just kind of division, or the reverse of multiplication. Their answer, my answer the same. I just kind of showed how I got there. So on the back side, I want you guys to pause me, take a second, try to find the largest integer, number and letter, that can go into each of these terms. Okay, you know what? I read this better. You are just finding the integer first. The next section, you're finding the largest variable. Okay, so we're splitting it into 2, then we're going to put it together. So question 5 asks us to find the largest integer. If I look at my factor chart, I notice between the numbers 9 and 45, they share the factor 9. So that's the biggest number I'm going to pull out. I'm actually going to skip down to question 9. I'm just going to do these parts all together. I noticed that both terms don't have a variable, so there's no variable that I can pull out. So now I'm going to skip down to question 13. Since I am taking out a 9, that's going to go outside my parentheses, and then I can think about dividing each of these terms by 9. So I'm left with x plus 5. This is the factored form. If I were to work backwards, I would distribute this back through, and I can check my answer. As long as I get back to the original, I'm good, and I do. So I'm just going to leave it in the factored form, like so. All right, on to question 6. I'm looking for the biggest number I can take out of 7 and 21. If I look at my factor chart, 7 and 21, and the biggest number that exists in both is 7. So my answer is 7 here. Letters, we don't have a factor chart for. You're just looking for the thing with the largest degree of x that can be factored out of all the terms. Well, that's just x, okay? So I'm going to skip over to question 14. Put these together. My GCF is 7x. So I'm going to put that on the outside of my parentheses and then divide each thing by 7x. That gives me x. Negative 21 divided by 7 is negative 3. And the x's cancel. Once again, I can check this by distributing back through. I'm not going to, but it is an option. Okay, next I'm looking at 18 and 12. I know my GCF number-wise is 6 there. I can go back to my factor chart. What was it, 18 and 12? The biggest number in both of these lists is 6. The most amount of letters I can take out is x cubed. So I'm going to skip over to question 15. My GCF is 6x cubed. That goes outside of my parentheses, and then I divide each term by that to figure out what goes inside. 18 divided by 6 is 3. 6x over, x cubed. X to the 6th divided by x cubed, there we go, becomes x to the 3rd. So we have 3x to the 3rd. Next term, 12 divided by 6 is 2, and the x cubes cancel out. Once again, you can distribute through to check your work to make sure you get back to the original. Okay, last one. We actually have 3 terms, so we need to find the GCF between all 3 of these. So numbers-wise, we're looking at 15, 25, and 55. So we have 15, 25, 55. The biggest number in all of these is the number 5. So numbers-wise, that is our GCF. Letters-wise, the biggest one we can take out is just x. So what goes outside of our parentheses here, we put those together, is 5x. Then we divide each of these by 5x. So we have 3 x squared minus 5x plus 11. Okay. All right, so now we're not going to break it down step by step. It says to factor polynomials, find the greatest common factor, GCF of the coefficient, and factor it out. Divide each term by the GCF. Then find the greatest common factor, GCF of the variables, by finding the lowest power of each variable. That will divide all terms and factor it out. Divide each term by the GCF. Move the GCF to the outside and write in parentheses what is remaining after you factor out the GCF. So this is basically what we've been doing and is how you will solve these next few problems. All right, so on these, reference your factor chart. I'm not going to reference back to it a bunch of times. I'm just going to tell you what it is, but you can look, find your biggest numbers. I know my GCF on this one is 6, and the biggest letter I can pull out is X. That goes outside my parentheses, and then I divide each of these by 6x, my GCF. My 6's cancel. X squared divided by x just becomes x. So I can bring that down. Negative 24 divided by 6 is negative 4. The x's cancel. Once again, you can distribute to check. Okay, this next one. 14 and 35 have a number GCF of 7 and a letter of x. So those go outside the parentheses. Now I divide, and I am left with 2x minus 5. Question 19 does not have a number GCF because 1 and 5 only have one alike. And that's not helpful, but it does have a letter that we can take out, which is just x. So we're left with 5x plus 1 with x on the outside. Now guys, this can be confusing. Don't think that that just completely goes away. When this cancels, it becomes 1. That's why there's a 1 there. That way when you distribute the x back through, you get your x plus x and not nothing, okay? All right, so these are the answers to those last 9 problems. Notice for the last 3, it says if the leading coefficient is negative, always factor out the negative. That's super important. So I did. That's why there is a negative in front of each of these. This is all we have for today. We are basically going to do factoring the rest of this year, so this is just an intro for us. If you have questions, make sure to ask them because we're going to be using this a lot.